Hi everybody, I'm Scott and this video is going to be made in haste. I just got this from Home Depot. It's the ecobee3 smart thermostat with Wi-Fi connectivity. The reason I'm doing this in haste is because my thermostat died and I'm going to replace it with this. And right now I have my air conditioning running via a jumper across two of the leads on the thermostat. I'll explain why that works and why that's not as stupid as it looks later on in the video. But for now, I just want to show you what's inside the package here while it's still in the package, because it's going to be on my wall in a second. And I'm going to show you how to install it too. So you have that to look forward to. This isn't just an unboxing. In fact, I'm going to blow through the unboxing pretty quickly. All right, it says this works with the Apple HomeKit. It's supposed to work with the Alexa, which I do have. That should be interesting because in general, I find the Alexa to be somewhat useless in my daily life.
Sorry, I didn't understand the question I heard.
But this might add a dimension of usefulness. All right, so we got that out of here. Here's the actual thermostat itself. Just to give you an idea of size, here is an old 10-inch tablet, and it fits nicely on that. And this is actually smaller than I thought. This is the remote sensor. And this is one of the main reasons I chose this over the Nest, is because it has these remote sensors. My heating system is really stupidly laid out. And, do not use this if you have a C-wire. Interesting. I do have a C-wire, so I won't be using this, so we'll explore this later separately. And the reason I chose this over the Nest is because it has these remote sensors that can sense the temperature in a different room. And I think they might be motion sensors too. I'm going to look into that. But my cooling system is very stupidly laid out. It's one zone for 2 floors of the house. So the second floor is about 7 degrees cooler on average when the AC is running than the first floor. But of course, during the day, we spend most of our time on the first floor and we do not occupy the second floor. So the second floor is being cooled a lot more than the first, a lot more extensively. And that probably really messes up our cooling bills, our electric bill. So we'd probably be better off getting a second zone installed. But until then, I'm hoping that this temperature sensor at least helps a little bit to balance things out, even at the expense of overdriving the AC at times on the second floor. It also comes with these mounting screws. The back comes off, as with most thermostats. So that separates. And then, let me get this box out of here. And then okay, it looks like the back plate just pulls off. I thought maybe it snapped on there. I didn't want to break it, but anyway. So this back plate is what the wire is attached to. And then this attaches to the wall, and then the thermostat pushes onto that with these just straight pins on the back. Huh. I don't know what this is. It has almost has a 6-pin connector on the inside. I don't know if it's for a lithium battery, maybe. Oh, it also has a larger bezel, I guess, if you need to cover up some bad paint job or something. A quick start guide, an installation guide, which seems pretty robust. This is all, yeah, it's not multilingual, so it's like 40 pages of actual instructions in English, which is cool. Some ecobee stickers and wire labels. And of course it has a nice protective coating on it, and I also like the way the ecobee looks. I mean, the Nest has that retro thing going for it, but I'm not big on retro. I like modern and high-tech looking. So yeah, I'm gonna install this and get my cooling system back to some degree of normality. So let's watch that. Of course, when you're installing the ecobee, you won't have to do this part, but that's the jumper I had that was keeping my air conditioning running while the thermostat was dead. The first step in the installation is to uninstall your original thermostat, which involves taking out each of the wires. Now, these wires are not high voltage enough to electrocute you, but you still want to be careful not to short them out to each other. So I put a piece of electrical tape on the end of each wire to prevent them from shorting as I move them around and pull them through the case. I also labeled one of the red wires because I have 2 of them, just so I knew which was which. And then pulling it off the wall is a little tricky sometimes, just to not pull off the tape, but there it is. And it's off the wall. I had plenty of extra slack on these wires, which is a good thing in case you need to strip them back. There's the big bezel, which I needed to cover all that area, and there is the mounting bracket and the ecobee itself. So the wires pull through the mounting bracket, which is also the wiring harness, and it goes that way around. And now I had a problem here where the hole that they drilled for the wiring was a little bit big, and the holes for the ecobee's mounting plate are very closely spaced. So you might well run into this problem. I don't know what the best solution for you is going to be, but the bottom hole worked out fine. The top hole was a little too close to where the drywall was all busted up, so this anchor did not seat well. I knew when I was hammering it in that it wouldn't work, but yeah, it just poked straight through the drywall. So I went downstairs and dug through my nuts and bolts and found a solution. If you don't have a good washer and nuts and bolts, you could always use a butterfly anchor in this circumstance, probably. I'm not sure what will work best for you, but this is what I did. Stuck that in there and then just sort of tightened it down while holding back against the washer and nut. And it actually attached pretty solidly, so I was overall pleased with that. Bottom screw went in just fine because that anchor was well placed, and it's solidly mounted to the wall. Next step is wiring it, which is pretty easy. You can follow the directions in the ecobee manual, but in my case it was very simple because I was just connecting the same color to the same color. And I had labeled my red wire, so it was very easy to know which was which. And here is a close-up of it, just in case you were curious. That is basically how my relatively simple system is wired. So now I'm back, and I'm going to install the ecobee. There's 5 pins on one side and 6 pins on the other, and those line up with the holes in the mounting plate. And the ecobee just pushes on. The only thing holding it in place are those pins, so to get it off again, you just pull it off the wall. It's very polite, it says hello, and then asks for a moment while it gets ready. And I'm going to cut this a little bit because this takes quite a bit longer. I just want to show you the cute little bee that shows up. First, it asks you if you have cooling only or heating and cooling. I had both. It confirms the wiring that's hooked up to it. It's pretty cool that it detects that. And then it asks if you have anything like a humidifier, dehumidifier, ventilator. I do not, so I selected no. And Fahrenheit or Celsius, I went with Fahrenheit. Now, equipment configuration, you might have more options than I do because it based this off your wiring, but from your wiring, it doesn't know if you have a furnace or boiler, so I had to tell it I have a boiler. And there's no options for me in cooling or fan, so moving on. It asks you to name the ecobee, which is great if you have multiple thermostats, and so I selected upstairs because that's where this thermostat is. And as for my ideal temperature in the winter, I like it cool, so I selected 64. And then the next option is going to ask the same thing about the summer, and I like it cool then too, but I don't like to use tons of electricity, so I set this to 75. And the current mode of my HVAC system is cooling because it's the summer. And this smart home away functionality is sort of the party piece of any smart thermostat. It detects when you're home and optimizes the heating and cooling for home and away cycles. So at first I was going to disable it. I decided to enable it because I want to try it out and see if it's actually worth using. After a couple of simple settings regarding date and time, it goes into the Wi-Fi setup, which they made really easy. You can either use your phone or select Wi-Fi network from the device, which I did, and my networks came up right away. Connect to it, and I entered my password, which I'm not going to show you, and then it configures the Wi-Fi, which it did very quickly. This is in real time, and I'm kind of impressed. Connects to ecobee.com, and by the way, you need to connect to ecobee.com to use any of the remote web-based functions. And not just web-based functions, but app-based functions on your phone as well. It now got a registration code from ecobee, which I need when I'm setting up my ecobee account to link my thermostat to my account. So while it's calibrating, I set up my account with ecobee, and then I'm just checking out the menu here, just if you wanted to see it out of curiosity. If you want to delve deeper into it, you can probably download the manual online, but there's my registration confirmation, which comes up on the thermostat automatically. I confirmed it, and now I can see my weather because ecobee knows where I am. And by the way, here's how easy it is to set up the app. This is on Android, but it's going to be pretty much the same process on an Apple device. And I'm already registered, so I just logged in, and it loads pretty quickly. And you can see here, if I change the temperature on the phone, it syncs up nicely with the thermostat. It's pretty quick too. And it was a good choice to make the phone interface the same as the interface on the actual thermostat because that makes it really easy to use. Alright, here's a remote sensor that the ecobee3 comes with. You pull out the tab to connect the battery, and pretty much right away, the ecobee detects it and asks you if you want to pair, which of course I did. And it pairs pretty quickly and asks you to name the sensor. And I'm going to keep the sensor on my main floor, so I'm going to call it main floor. And since I don't sleep on my main floor, I'm going to uncheck the sleep box. I think that's the right option. and this sensor will just detect whether I'm home or away, and it congratulates me, so that's cool. And now here it shows the sensor settings, and it shows the temperature upstairs and on the main floor. And the only remaining feature, I guess, of the little remote sensor is the fact that the battery compartment cover can be replaced with the little stand. And the little stand is nice because, I mean, what else are you going to do with this thing? You need to keep it somewhere where it can sense movement, so I kept it on my coffee table for now. And that's pretty much all there was to installing the ecobee3. Alright, so the ecobee's installation didn't go off flawlessly, but in the end it works, and it's up there right now running the air conditioning and doing a good job of it. What I wanted to talk about was the wiring itself, because thermostat wiring can be very intimidating. There's a lot of wires just with arbitrary colors and weird names, and it's really not that complicated unless you have some kind of crazy system with heat pumps and auxiliary heating and I don't know what else, dehumidifiers for your AC. So I have this mocked up right here. You can ignore most of the stuff on this breadboard. It's really just, most of these components are just to run the LEDs. And these red LEDs indicate that the heating system is on, and these yellow LEDs indicate that the cooling system is on. In retrospect, I probably should use blue LEDs for cooling, but whatever. Somewhere in your house, you probably have one of these. It's not necessarily connected to a box like this. It might be inside your boiler or somewhere inside your air conditioning unit, but it's going to be a 24-volt transformer. It takes 120 volts in if you live in the United States. If you live elsewhere, it might be 240 volts in, but it outputs 24 volts AC. Now it's AC, not DC, which is why I have a couple of rectifiers here to run the LEDs, because I wanted it full wave so that they're brighter, but anyway, so they don't flicker as much on the camera. That's kind of besides the point. So somewhere in your house, this is putting out 24 volts AC. You might have more than one of these. In fact, you probably do, because you might have one for your cooling system, one for your boiler, one for your doorbell. And if you have multiple zones, you might have multiple transformers. I have two of them, one for my AC unit and one for my boiler. But like I said, the wiring looks really complicated, but it's not that complicated. I'm going to turn this thing on, and you see the thermostat comes on. So if I open it up and I set it to cool, the set point is 85 right now, which is the default. So if I bring this down below 72, it's going to want to turn the cooling system on. And this thing's fairly slow to move, so 71, and the cooling system comes on. And then if I change it over to heat mode, like it was the winter, it defaults to 62. So it's reading 72 on the thermometer. If I turn it above 72, the heating system should come on, and it does, which is great. This thing's working like it should, which it wasn't when it was on my wall, which is weird, but whatever. And anyway, this is inaccurate, so it needed replacement regardless. And by the way, this thing does have a program mode. This is a very cheap thermostat. I'm gonna guess maybe 20, 30 bucks, and it's probably also about 20 years old. And it did go the distance, so I'm pretty pleased with it as far as that goes. I don't know that the ecobee will last 20 years, and even if it does, it'll probably be obsolete. So I'm not too excited about that, especially since it costs probably 10 times as much as this thermostat. So this one does have a program mode, which most of these do. And I had this program pretty well to turn on and off when we were and weren't home. So I don't know how much energy savings I'm really going to get from a smart thermostat, because I programmed this fairly intelligently. So it's not like I'm going to save shitloads of cash by switching to this. But this is far cooler, and I like the fact that I can remote control it, so that's really why I spent the money. It was for the coolness factor, not so much for practicality. So let's start with the transformer. Now the transformer doesn't power your heating or cooling system, or at least not directly. It powers relays in your heating and cooling system, which then actually provide the juice to the compressor, to the fan motor, and to whatever else you have in there. And it has two terminals, a load and a common, or hot and neutral, depending on how you want to look at it. It's AC, so it's really either or, but they are labeled, so we'll go with that. So the thermostat basically just either passes current or doesn't pass current. It's very simple. In fact, there are a couple of relays in this, so it's actually relays on top of relays. But it just acts as a switch. When it hits a certain temperature, it turns power on. When it hits another temperature, it turns power off. There we go. So these three LEDs would just represent a relay in your boiler in this case, since it's the heating side. So all this does is switch power on and off. That's in essence what it is a switch. Even this much more complicated device its real purpose is just to turn power on and off, open and close a circuit. Now you might hear a lot about a C-wire. If you're looking at thermostats, some of them will say a C-wire is required, others say it isn't. This actually has a special adapter box. A C-wire is nothing fancy. All that means is it's the common wire. It's just a line going back from the thermostat directly to the transformer. Because otherwise, if you don't have a C-wire, if this wire doesn't exist, because this is coming from the common to the C terminal on the thermostat, now you might say that's no problem because you have these two wires which are providing power to the thermostat. They're hooked up to the load terminal and they go into the thermostat, and therefore you have 24 volts AC at the thermostat. The problem is there's no return path for that current unless the heating or cooling system is on. Some thermostats will actually recharge themselves when it's running the heating and cooling system because it's a complete circuit. But when the heating or cooling system's off, the thermostat would have to run off of its batteries, which might eventually die. So the common wire just allows current to flow from this terminal in the transformer into the thermostat to power the thermostat itself, and then for the power to come back to the transformer. And that's all the C-wire does. That's the only purpose of it, is to power the thermostat itself. It really has nothing to do with powering or controlling your heating and cooling system. Now I have two wires here that are both connected to the load terminal. Now, like I said, in my house I have two of these transformers, one in the cooling system, one in the heating system. So in fact, these two wires would be separately going to each of those two transformers. But for demonstration purposes, I only have one, so I just hooked them up to one. And these two wires go to terminals called RH and RC. I actually don't know what the R stands for. It's usually indicated with a red colored wire, but the H stands for heating and the C stands for cooling. And the R, even the transformer has an R on it, is in essence your power in. And so RH or RC is just the power coming from either your heating transformer or your cooling transformer. The other two important connections here are the W and Y connections. The W connection usually is indicated by a white wire, the Y connection by a yellow wire. That's the convention. That's not necessarily the way it will be in your house or the way it has to be, because they're just wires and colors don't really matter when you're conducting electricity. But it does make it a lot easier when they use the correct colors. And the W is just the current return path for the heating system. You can see I'm using a white wire as appropriate here. And for Y, I didn't have a yellow jumper long enough, so I am confusingly using an orange wire. But this orange wire is connected to the Y terminal, which is for the cooling system. And this thermostat, like most others, has additional terminals, like the G terminal for a fan or blower unit, and the B and O terminals, which are used for heat pumps for reversing valves, something which I don't have and didn't have hooked up, but you may well. And again, in most cases, they're just going to be for turning a relay on and off. These are just switches. It's nothing more complicated than that. The thermostat doesn't talk to your boiler in any kind of high-tech protocol. I mean, it might if you have a particularly high-tech system, but if you have a system like this with these kind of wires, it's just turning them on and off. You might also have a W2, which would be a second stage of heating, and you might have a Y2, which would be a second stage of cooling. Again, I don't have those. This thermostat doesn't support them, so it doesn't matter, but the ecobee does. And when you're going from your old thermostat to the ecobee, they provide a lot of examples in their manual about how to hook things up. If you have a thermostat like this, you can hook up the ecobee like that. Hopefully your wiring is color-coded appropriately, and that makes it a lot easier. If it's not, make sure you label the wires before you take them off your old terminals. And if you don't have a C wire, but you know where your transformer is, and it's fairly easy to run wiring from your transformer to your thermostat, then you can drop a wire from the C terminal to the C terminal on your transformer, and there you go. You can have a powered thermostat. All right, so now I just want to take a quick look at the C terminal replacement interface box that came with the ecobee. All right, so here it is. And it says, do not use this if you have a C wire. Does this split apart? Yeah, that just splits apart. Okay. All right, it's got a terminal block for connecting your wires, and then it's got these leads which go to the ecobee. So your wiring would come in here. And you see you got RRHRC, which is just one connection. So you really can't have heating and cooling with this, I guess. G for the fan, Y for your cooling, and W for your heating. Okay, inside of here, looks like we got a couple of... I just wanted to give a couple of my final thoughts on the ecobee and smart thermostats in general. I like smart thermostats because they connect via Wi-Fi and you can access them from anywhere and turn your heating or cooling system on or off if you're coming home from work early or whatever you're doing. It makes it more flexible. I mean, let's face it, it makes it more fun. You can use your Amazon Echo to control it, which is cool and futuristic. Although realistically, I mean, programming this and just leaving it alone worked pretty well. But like I said, this thing lasted about 20 years. I don't see this ecobee lasting 20 years or anywhere near that. Not just because of its inherent longevity, just as far as the electronics go, but also as far as it being supported in 10 years or 20 years. I mean, I don't think, maybe this company will be around in 20 years, but even if they're around, they're not going to be supporting this old ass thermostat anymore. You know, how often is something on your cell phone or computer crashed? This is relatively complicated software in here, especially for a simple thermostat, much more complicated than this. So the chances of it failing are much higher than this failing. And of course, if you live somewhere where it's very cold and let's say it's well below freezing out and you're on vacation and your thermostat fails and the temperature in your house drops, you can end up with burst pipes and water damage and all sorts of other crap. So reliability is really something to keep in mind when choosing a thermostat. I mean, I think more so than the looks of the unit or the feature set. I mean, let's face it, you're putting your entire house, I mean, if you live in a cold climate where your pipes could freeze, you're putting your entire house on the line if you buy one of these for reliability. So, yeah, smart thermostats, I like them. I got one. I mean, I paid money for this. It's not like I got this for free. So, it's good enough to make me shell out the cash, but not so good that I'm amazed by it or blown away with the concept, because it does have its shortcomings and failings compared to a old-fashioned, shitty, cheap thermostat. But ultimately, if you want reliability, if you want something that's going to last you 20 years, don't pay a lot of money. 30, 50 bucks at most. Get you a nice thermostat that you can program, and if you program it well, it'll still save you money in the long run. Maybe not as much money as this, but how long is it going to take you to save you 200 bucks? Anyway, I'm Scott. Thanks for watching. Please subscribe if you like this. If you didn't hit the dislike button, whatever. I'm really bad at saying goodbye. Goodbye.